Go to your bathroom, turn off the overhead light, and shine your phone's flashlight directly across the mirror you just cleaned yesterday. You will see it. Not dirt, not dust. A hazy, swirling film of streaks that seems to live permanently on the glass surface. For years, when you saw those streaks, you thought you just did a bad job wiping. So you sprayed more blue liquid, wiped harder, and hoped for the best. You didn't fail at cleaning your mirror. Your glass cleaner is failing you. The streaks on your mirror are not a sign of a dirty bathroom. They are the chemical residue of the exact product you bought to clean it. The blue liquid in the spray bottle contains surfactants, solvents, and, in many formulations, a small amount of silicone or polymer compound added to give the glass a temporary shine after cleaning. These compounds do remove the fingerprints and watermarks and surface contamination you're trying to clean. But they also leave a thin, invisible film of surfactant and polymer residue on the glass surface. And when this film dries, it does not dry uniformly. It pulls into irregular patterns as the liquid evaporates, producing the streaks and haze that appear on the dry mirror. And every subsequent cleaning with the same product adds another layer of residue to the accumulating film. Over months and years of regular cleaning with commercial glass cleaners, a mirror accumulates a significant polymer and surfactant film that progressively reduces its optical clarity. The mirror that looked brilliant when it was installed looks permanently dull no matter how recently you cleaned it, because the cleaning product is part of the problem. The combination that removes this film completely, and that cleans glass without leaving any residue of its own, costs under $1 and has been used by professional glaziers and glass manufacturers for cleaning optical surfaces since newspapers existed. White vinegar and newspaper. The acetic acid in white vinegar dissolves the polymer and surfactant film that commercial glass cleaners deposit. The slightly abrasive surface of newsprint, carrying a carbon-based ink that does not transfer to glass surfaces, polishes the glass at the microscopic level as it removes the dissolved film. No residue, no streaks. A mirror surface that is genuinely clean rather than clean-looking. We have been conditioned to associate the smell of artificial ammonia and blue dye with cleanliness. I'm here to dismantle those expensive illusions. If you are tired of paying a premium for products that manufacture the very problems they claim to solve, hit subscribe and ring the bell. That is what $1 Miracle is built to do. Because today, we are going to strip years of chemical buildup off your mirrors using something that costs $0 and is currently sitting in your recycling bin. Let me show you exactly what happens to a mirror surface over years of commercial glass cleaner use and why newspaper and vinegar reverse it completely. Glass is an amorphous solid, a material with no crystalline structure whose atoms are arranged in a random, disordered network rather than the regular lattice of a crystalline material. The surface of a glass mirror is, at the atomic scale, an irregular landscape of silicon and oxygen atoms with a characteristic surface energy that determines how strongly other materials adhere to it. This surface energy is the property that makes glass easy to wet. Water spreads across glass readily, and also the property that makes glass prone to retaining thin films of any liquid that contacts it. Commercial glass cleaners exploit this surface energy during application. The surfactants in the cleaning solution reduce the surface tension of the liquid, allowing it to spread uniformly across the glass and carry the dissolved contamination, the oils, minerals, and organic material, away from the glass surface as the liquid spreads. This is the cleaning mechanism. It works. The contamination is removed. But as the cleaning solution evaporates, the dissolved surfactants and any polymer additives in the formulation are left behind on the glass surface. They cannot evaporate. They are non-volatile compounds dissolved in the volatile water and solvent carrier. As the carrier evaporates, their concentration at the glass surface increases. They deposit as a thin, solid film. This film is not uniform because the evaporation of the carrier liquid is not uniform. The edges of the liquid front evaporate faster than the center, pulling dissolved compounds toward the perimeter and creating the characteristic streaking pattern of uneven film deposition. The silicone and polymer compounds added to many commercial glass cleaners to improve the post-cleaning shine are particularly persistent. They adhere strongly to the glass surface through the same physical forces, van der Waals interactions, and electrostatic attraction, that give glass its characteristic surface properties. They do not dissolve in water. They require an acid or a specific solvent to remove them. Standard glass cleaner is neither. It deposits them. The film builds with each cleaning cycle. The optical clarity of the mirror decreases as the film thickens. The mirror that you clean every week is less optically clear than the mirror you bought, not despite the cleaning, but partly because of it. Now let me show you what vinegar and newspaper do to reverse this process. White vinegar, typically 4 to 8% acetic acid dissolved in water, is mildly acidic at a pH of approximately 2 to 3. This acidity is sufficient to dissolve the polymer and surfactant films that commercial glass cleaners deposit on glass surfaces. The acetic acid disrupts the van der Waals adhesion between the polymer film and the glass surface by competing for the adhesion sites on the glass. the hydroxyl groups on the glass surface that the polymer compounds bond to. The polymer compounds are displaced from the glass surface and taken into the vinegar solution. The film dissolves. The process is not dramatic. You're not watching a visible reaction. But the result is a glass surface that, for the first time in months or years of cleaning, is genuinely free of the polymer residue layer that has been accumulating on it. The newspaper provides a second mechanism that complements the acid chemistry of the vinegar. Do not think of the newspaper as a paper towel. Think of it as a 100,000 grit sandpaper made of cellulose and carbon ink. It does not just absorb the vinegar, it physically shaves the dissolved polymer film off the glass without scratching it. The paper fibers of newsprint, when used to wipe a glass surface, act as a micro-polishing medium, contacting the microscopic high points of the polymer film on the glass surface and abrading them away with a gentle mechanical action. This abrasion is insufficient to scratch the glass. Glass has a Mohs hardness of approximately 5.5, and paper fiber is significantly softer, but it is sufficient to mechanically assist the removal of the softened polymer film that the vinegar chemistry has been attacking chemically. The carbon-based ink in newspaper printing has an additional property relevant to this application. The ink particles are small, hard carbon deposits on the paper surface. When the newspaper is used to wipe glass, these ink particles provide a slightly more abrasive contact than the bare paper fiber would, enhancing the micro-polishing effect without approaching the hardness required to scratch the glass surface. The ink does not transfer to the glass because the glass surface is smooth and non-porous relative to the paper surface, and because the mechanical force applied during wiping is directed along the glass surface rather than perpendicular to it. The combined effect of the vinegar's acid chemistry dissolving the polymer film and the newsprint's mechanical micro-polishing, removing the dissolved material, leaves a glass surface that is optically clean at the level of the glass material itself, not clean to the level of the last commercial cleaning product residue. A study published in the journal Surface and Interface Analysis in 2009 characterized the polymer and surfactant film accumulation on glass surfaces cleaned repeatedly with commercial glass cleaners versus surfaces cleaned with acidic solutions and fiber-based wiping media. Glass surfaces cleaned with commercial glass cleaner 20 times showed a measurable increase in surface roughness, 0.8 nanometers average increase, attributable to the accumulated polymer film. Optical transmission, the proportion of light passing through the glass without scattering, decreased by 3.2% in the commercial cleaner group. Glass surfaces cleaned with dilute acetic acid and fiber wiping showed no measurable increase in surface roughness and no decrease in optical transmission over the same 20-cycle cleaning protocol. The commercial glass cleaner was measurably degrading the optical clarity of the glass surface with each cleaning. The acetic acid and fiber combination was maintaining the original optical clarity throughout. 3% optical transmission reduction sounds small. On a bathroom mirror, it is the difference between a mirror that looks brilliant and a mirror that looks permanently dull. Why would a cleaning company add ingredients that make glass progressively cloudier over time? Because they are not selling clean. They are selling shine. And shine, the temporary visual impression of clarity produced by a fresh, wet surface, and actual optical cleanliness are not the same thing. The industry does not hide this because it is a secret. They overlook it because you cannot build a billion-dollar glass cleaning business by telling people to use yesterday's newspaper. The global household glass and surface cleaning market generates several $billion annually. Glass cleaning products represent a significant and recurring purchase category. Windows and mirrors are cleaned frequently. The products are consumed quickly, and the consumer returns to the shelf regularly. A cleaning system that uses white vinegar at 20 cents per application and newspaper that is free, already read and headed for recycling, eliminates this recurring purchase entirely. The transition from commercial glass cleaner to vinegar and newspaper reduces the glass cleaning product purchase to zero. No glass cleaning brand has a commercial interest in communicating that this transition produces superior results. Consumer glass cleaning guidance is produced in a commercial context, by cleaning product brands, by household cleaning media whose advertising revenue comes from cleaning brands, and by platform content that is similarly supported. The vinegar and newspaper technique is widely known in professional cleaning communities. Window cleaners, auto detailers, and mirror installation professionals use variations of it routinely for the same reasons the science explains. It is absent from mainstream consumer cleaning guidance because its adoption removes the consumer from the glass cleaner purchase cycle entirely. Standard glass cleaning guidance recommends commercial products because commercial products generate the revenue that sustains the guidance ecosystem. Here is exactly what to do. This is the part that no glass cleaning brand has ever included in its consumer recommendations. Purchase white distilled vinegar from any grocery store. Standard white vinegar at 4 to 5% acidity is ideal. Do not use apple cider vinegar or wine vinegar. The color and additional organic compounds in these products can leave their own residue on the glass. White distilled vinegar is clear, inexpensive, and leaves nothing on the glass surface after evaporation. Collect several sheets of newspaper. Any standard newsprint works. Avoid newspaper with glossy advertising inserts or magazine quality pages, which have a smoother, less abrasive surface that reduces the polishing effect. Standard newsprint from daily newspapers provides the optimal fiber texture and ink particle distribution for glass polishing. Fold a sheet of newspaper into quarters to create a firm, manageable wiping surface. Pour a small amount of white vinegar, approximately 2 tablespoons, into a small bowl or directly onto the folded newspaper. The newspaper should be damp but not saturated. Excess vinegar on the newspaper will pool on the glass surface rather than being applied and removed in a single motion. Apply the damp newspaper to the mirror surface and wipe in circular motions, working from the top of the mirror downward. Apply moderate pressure, enough to ensure firm contact between the newsprint surface and the glass, which is what drives the micro-polishing mechanism. As the newspaper becomes saturated with the dissolved polymer film and the evaporated vinegar, refold it to expose a fresh surface or replace it with a fresh piece. Continue until the entire mirror surface has been wiped. Immediately follow with a dry sheet of newspaper. Use dry without vinegar, wiped across the entire surface in the same circular motion. The dry newspaper removes the vinegar solution and the dissolved polymer material from the glass surface, leaving no liquid residue to dry and streak. There is no rinsing required because the vinegar leaves no film as it evaporates. There is no buffing required because the newspaper has already polished the surface to its final clarity as part of the wiping motion. The mirror will be dry and clear within 30 seconds of the final dry newspaper wipe. For mirrors that have been cleaned with commercial glass cleaner for years and have a significant accumulated polymer film, mirrors that look dull even immediately after cleaning, the first vinegar and newspaper cleaning will show dramatic improvement but may not achieve full optical clarity in a single treatment. The accumulated film may require 2 to 3 cleaning sessions over consecutive days, as the vinegar dissolves the outermost layer of the film and the subsequent session addresses the layer beneath. After 2 to 3 sessions, the mirror will have reached its original optical clarity, and subsequent cleanings with vinegar and newspaper will maintain this clarity indefinitely. For bathroom mirrors that are regularly exposed to hairspray, which deposits a polymer film of its own, similar in composition and adhesion to the polymer films in glass cleaners, increase the vinegar concentration slightly by using it undiluted, rather than at the standard 4 to 5%. The higher acidity accelerates the dissolution of the polyvinyl pyrrolidone and other polymers in hairspray formulations. A mirror is just molten sand cooled into a perfectly smooth surface. It does not need polymers. It does not need artificial shine enhancers. And it certainly does not need a $4 bottle of blue dye. It just needs a reset. Grab some vinegar, grab a newspaper, and go look at yourself in a mirror that is actually clean for the first time in years. Drop a like if you are throwing that blue bottle away today. I will see you in the next one.